All right. Let's get me out of here. Kind of jump into week 2 stuff. So we left off last class. I think I gave you a quiz. I think I had it set to be due before we started the class today. So hopefully we got on and got that done. We should have been over what we went over the majority of on Friday, which was looking at these production values, determining costs for the different 2 parties, and then talking about things like comparative, absolute advantages. We then started kind of saying, well, there's actually not 2 people in an economy, there's actually several people, right? So maybe we've got these production possibilities curves where we first start producing that x-axis good, using the person, the state, the country, whoever that can produce that the lowest cost, right? But that as we kind of progress and we want to produce more and more of that X good, we've got to go to the next person, eventually someone uses all their resources and we have to move on to the next person or the next state that can produce that good. And they're going to do it at a higher cost, right? Kind of represented by, we start getting this steeper and steeper production possibilities curve or the steeper and steeper production possibilities frontier. So one thing that we want to start thinking about is what would we ultimately want to do? So we talked last class, I don't think I have the slide up here, but any point on the curve we said was what? Remember? Efficient. We're using all of our resources to produce some combination of this X and Y good. Any point past that, we said it was not feasible. We don't have enough resources to get out further. So shifts in this production possibility curve as an economy, we'd ultimately like that, right? I'd love if the entire curve shifted out because that represents now that I have more resources, right? Or at least given the resources I have, I can produce more of each of these goods, right? So we can think about things that would only impact 1 or 2 of these goods. So a major one might be, let's say I have like a technology improvement. So I think, let me see if I have a slide here. I don't think I do. I'm gonna probably do it on the board, yeah. So let's think about here. I'll give you some actual. This might make a little more sense. I don't line it up. So we've got. Oh, I don't know. Call this wool production, and we'll call this computers, right? So we might think about there's some technology improvement where before here was my production possibilities curve, right? I don't know. Call this curve A. And basically, this technology improvement, whatever it was, doesn't apply at all to wool production, but it allows me to produce several more computers. Whatever this technology improvement was, maybe the way the microchips were created, I don't know, right? So that if I'm only producing computers, I can now, with this new technology, produce a lot more of them. However, if I was only producing wool, this technology doesn't play a role at all in wool production, so that point would stay the same. Well, now my new production possibilities curve, right, kind of has this shift out, right? But it only shifted on kind of one good, right, or one kind of axis. Now, we could see technology improvements, like just general, I don't know, like human capital, right? If we just have more people who are developing skills, going to college, however we want to market into this, right? We could see, we have it here, right? An entire shift, right? A shift in both axes. Doesn't matter what we're producing. Having a more educated populace means that whatever we choose to produce, we can now produce more of it. Doesn't matter if it's the X good, we're only producing this X good, we can now produce more of it. Or if we're only producing that Y good, we can also now produce more of that as well. Then we would see kind of this like parallel shift out in our production possibilities curve. And this would be better, right, than only having one of them shift. But we can always dictate whether or not that technology improvement, whatever factor that is changing, that's allowing us to produce more. We can't say that it's going to apply to both goods equally. It just depends on the situation. Yeah.
All right. One is related to this, and one relating to what we talked about. Also on this, how do you know which PPS like is better based on the numbers of this?
Yeah. So if I'm looking at these 2 production possibilities curves of frontiers, it's not that any point on these curves are necessarily better than the other, right? Let's say this was my economy and I was producing, this many of the X goods and this many of the Y goods. I can't say that this point is any better than this point up here, right? They're just both representing a point where I'm using all of my resources. It's a much longer discussion about what the optimal point on is here. We can start talking about things like utility curves, so kind of down the road, right? For now, we're just trying to understand in this economy, what points or what combinations of these two goods am I using all my resources? Now, I think this isn't necessarily a normative statement. It will be a positive statement to say that this other production possibilities curve from here, the second one, that's further out is desired more than the first one. Why? Well, because it doesn't matter what, like if I choose any X value here, let's say I want to produce 250 of this X good. Well, in the second economy, if I'm producing 250 of this X good, I can also produce even more of the Y good as well. If I wanted to produce 200 units of the X good. Well, in the second economy, I can produce that many units of the X good, but also more units of the Y good as well. So any point on that second production possibility frontier, since it's further out, is actually better, right? I'm getting more. Think about it this way. I am, at the very least, keeping the amount of one good the same and then increasing the amount of the other. Now, if I wanted to, I can increase both. I just kind of, a way to think about it, I think that is better is at any X value here, in that second economy, we can get to a higher amount of the Y value, or the Y good as well. So we like to see these pushes out, right? These shifts out in our production possibility curves. This means we can produce more of either one of these two goods. Now, if it goes in, let's say, I don't know, we hit the dark ages or something, or something hinders the production of specific goods. Well, this is actually bad, right? Because now all these points before, which were feasible, I just wasn't using my resources. So we said any point below the production possibilities curve was inefficient. We just weren't using all our resources. Well, if I see a shift in my production possibilities frontier downward, well, now all these points before that were inefficient. Well, now they're actually just not feasible. I can't even get to those points. All right. It's better to be inefficient and then not be using your resources than not be able to even get to those points. Right. But we rarely see kind of this decrease in our production possibilities curve. Maybe occasionally throughout history we can think about this. Generally think about it's always kind of progressively moving out further and further. Any other questions kind of related to that production possibility frontier shifting? Okay with this idea? Or no? So, where were these curves coming from? Right? They're originally coming from these values where we said if a country or the person or a company are using all their resources, they can produce, and we chose two goods. We said we can be very specific about these goods, or we can kind of keep them to be general sectors, right? Technology sector versus the agriculture sector. That makes more, practical sense to think about it that way. But I think to really hammer the idea home, using specific goods usually helps. So here, instead of small and large jets, to not make it too complicated, I chose two very different, jets or automobiles, right? They both require very similar raw inputs. And so I can have my populace, given our, whatever resources we have, we can only produce jets or we can only produce automobiles. And if we do so, we've got these values, right? I kept the values the same as what we used last week, just to make the math a little easier, and hopefully we'll kind of see some familiar things. So we went through and said, okay, we could graph these out, right? We could plot, if they're only producing jets, how many can they produce? If they're only producing automobiles, draw a line between the two, the very basic production possibilities curve. We then said if we can calculate the slope of that production possibilities frontier, that production possibilities curve, that told us the price of which good. So if I drew this out, and I've got wool on my x-axis and computers on my y-axis, if I were to calculate the slope of my production possibilities curves, that tells me the price or the cost of producing what? One more unit of my X good. Okay. So the slope of that production possibilities curve always represented the cost of producing one more unit of that X good. So if we're doing this example here, got what? Field jets, if we think about the US, it was what, 30 jets. If we're only producing automobiles, it was 40, right? So I calculate this slope, right? The Y value is going from 30 to 0, right? So that was the change in Y over change in X told me my slope. So the Y value is going down by 30. The X value is going from 0 to 40. So I said the cost of one more unit of my X good, so the cost of producing one more automobile would then be that the US would have to give up producing 3/4 of the other good. So the cost of one more automobile is 3/4 of the jet. So that's how we were coming up with kind of that opportunity cost for a jet. Opportunity cost for an automobile in terms of a jet for the United States. Then we do the same thing for Brazil, right? Instead of 30 and 40, we have 10 and 30, right? Calculate the slope of that line. We get that the cost for Brazil producing one more automobile is 1/3 of the jet. So significantly lower. So we would say that Brazil has a what? An automobile production, if they can do it at a lower cost, they have a comparative advantage. How could I quickly come up with not just the cost of my X good, cars, right, or automobiles, but I wanted the cost of the Y good, jets. I said I could just split the numerator and denominator, or it's a reciprocal 1 over the old cost, but probably an easier way to just think about flipping that denominator into the numerator. So I get the cost of a jet in the US is 4/3 of a car. The cost of a jet in Brazil is 3/1 for 3 cars. Okay? So that could be a nice easy way to quickly come up with those costs. Okay?
So what do you compare this to?
Yeah, so we look at this. Who has the lower cost of producing a car? Well, 3/4 of the jet is more than 1/3. So we said Brazil has a comparative advantage in car production, right? Because their cost of producing a car is lower. If we look at the cost of producing a jet, who has the lower cost? Well, the US only has to give up 4/3 of the car. Brazil would have to forego producing 3 cars, much higher cost for Brazil. So US has the lower cost when it comes to producing jets. So the US would have a comparative advantage in jet production, Brazil comparative advantage in car production. And this idea is you can only have a comparative advantage in one of the two goods. You can have an absolute advantage like the US does here in both. If I used all my resources just to produce jets, or just to produce automobiles, I can produce more than Brazil. If I'm thinking about the US. So they have an absolute advantage in both, but only a comparative advantage in the good they can produce cheaper, which is jets. So if I'm thinking about this, if I have a comparative advantage, I can do something at a lower cost. Well, that's what I should be doing, right? So here, this will kind of lead us to think, well, the US should be producing jets, and Brazil here should be producing cars. If we're trying to be optimal, right? We're trying to get individuals to produce what they can produce at the lowest cost. Okay? So there might be a way for these two countries to then say, okay, look, the US says, look, we recognize that we could produce a combination somewhere between 30 and 40 jets, right? Maybe, I don't know, maybe they want to produce at this point on their production possibility. So they start to give up producing some jets and they start producing more automobiles. But then the US says, well, look, why am I doing this when I know that I'm giving up more of my jet production than if Brazil was to create these automobiles and I was somehow able to trade with them? Because I know they can do it cheaper than I can. So you kind of think about there might be some potential for gains in trade here. So any number of cars that's less than its own cost, right, would be an amount that the US could say, look, it's going to cost us what, 3/4 of the jet. So we'll pay Brazil any cost below that for an additional car. Because if we produce it ourselves, we're giving up 3/4 of the jet. So we'd be willing to pay Brazil or give Brazil half a jet, right? That would be a lower cost than if we produce it ourselves. Right, so let's assume the US comes to Brazil and says, look, we would love a car. We would love to start getting some automobiles for our citizens. For every car you give us, we'll give you half a jet. Okay? So for every car Brazil gives the US will give them half a jet. For the US, is that a good deal? Well, if they were to produce the car themselves, they'd have to give up 3/4 of the jet. So yeah, half a jet better than 3/4. For Brazil, is it a good deal? Well, they're like, well, if I wanted to produce kind of an entire jet, right? So they're going to give us half a jet. Well, if I want, what is it? If I want one more jet, Brazil has to give up 3 cars, right? If I think about here, to get one car, the US is going to give them half a jet. So a full jet would cost what? 2 cars, right? Well, 2 cars is way cheaper than what Brazil could do it on their own. So this kind of trade value, this half a jet for every 1 car, works for both countries, right? It's better for both those countries to then trade at this cost of, this value of 1/2 a jet for every car, and that would be beneficial to both. So the range of values that would be producing gains in trade is really anything that's in between the 2 costs of the country, right? If you were to choose, the cost of a car to be 1/6 of a jet, well, no, that's no longer great for Brazil. If we were to choose instead of 3/4, maybe we choose 3 jets for every car. Well, that's now more expensive for the US. But the only values that would really work for trade are going to be values that are somewhere in between the 2 costs of the country, right? Somewhere in between 3/4 of a jet and 1/3 of a jet. And we're talking about the trade value of 1 car. Okay. Any questions on that? I'll kind of give you a different way of thinking about it here. So let me think about it here. So I could come up with what those trade values are. I said the trade value that would work for both countries is if it's somewhere in between each country's cost. The 3/4, I believe it was 3/4 of a jet for the US cost, the 1/3 of a jet was Brazil's cost. So as long as we can choose some terms of trade in between those values, trade should be better off for both countries. Said differently, by setting the value of the cost of the car, we're inherently setting the cost of the jet because it's just the reciprocal of that. And we don't really have to worry, do the mathematical proof to show if I choose the cost of the car somewhere in this range, because it would just be the reciprocal, it would have to be somewhere in that range for the other 2 as well. So we really only have to focus on kind of one bit here. And I think the one that I'll kind of be using is the cost of that car. Okay. So let's think about if 2 automobiles for every jet, right? So cost of a jet, let's say we set the trade to be that if these countries want to trade, if one of them gives the other a jet, the other country has to give them 2 automobiles in return. And so that's kind of the trade value. So we could go and look at the US and say, okay, we want to get 10 additional cars. Before, if we wanted 10 additional cars, that was going to cost us 7.5 jets. So maybe, before trade, if we wanted to get the US to have 22.5 jets and 10 cars, they would have to give up 7.5 jets, but in doing so, they could produce 10 automobiles. And if Brazil wanted to do so, we would have their production possibilities curve drawn out. You can see that if they wanted to have 5 jets, they could, using all their resources, produce 15 cars, right? It was just a different point on their production possibilities. But if we allow for trade, and we allow for each country to do what it's good at, then the US will produce all 30 jets, right? That's what we said they had a comparative advantage in. So the US will produce all 30 jets. Brazil will produce what it could produce the most, or had the comparative advantage in, which was automobile production. And I believe theirs was what? 10 to 30. So they'll produce 30 automobiles. Now the 2 countries will come together. They only have 1 of each type of good. But we say, okay, the US needs at least 10 cars for its citizens. So it goes to Brazil and says, we want 10 cars. The cost for every jet is 2 cars. And you get 10 cars, the US would have to give up 5 jets. So they produce only jets. They then give 5 of them to Brazil. So they now have 25 jets left. And as a response to the US giving them 5 jets, Brazil gives them that cost of trade, or terms of trade they agreed on, which is 2 cars for every jet. And now the US gets 10 cars for those 5 jets it gives up. It is now better than it was if it tried to produce those cars itself, right? Because it has the same number of cars, 10, but with trade, it has 25 jets as opposed to if they did it themselves, they only have 22.5. Well, did this work out for Brazil, right? Well, Brazil is producing all automobiles, right? It gave up 10 to the US, which its terms of trade was for every 2 cars, 1 jet. So they gave up 10 cars to the US. In return, they got 5 jets. So now they get the same number of jets. So they were producing 30 cars, they gave up 10. They now have 20 cars, as opposed to when they tried to produce those 5 jets themselves, they only had 15. So this terms of trade, because it was in between the 2 costs of the countries, results in both of them being better off, if they can, agree to this process, right? As opposed to just do it on their own, right? Just try to produce the good on their own. Okay. Some questions on this? This is kind of tricky. So there will never be one specific like terms of trade value that works. It's always going to be a range of potential values, right? So there's different terms of trade that can work, that can benefit both countries here. It's just that depending on what cost we choose, it's going to benefit maybe one country a little bit more than the other, right? And generally that's like if I'm moving the cost closer to Brazil, then that's going to benefit Brazil a little bit more than it would the US and vice versa, right? Or if I'm moving it closer to someone's comparative advantage, then it's always going to be a little bit better off for that. I try to choose a number that's kind of right in the middle there. So in between 4/3 and 3, I chose 2. You could choose 2.41 if you wanted to, but generally I'll kind of, where I give you an example, I'll kind of keep it nice and neat at these integers. I wouldn't even be as complicated as this when I'm kind of dealing with 3rds and 4ths. I'd probably try to give you some like 1/2, 1/4, or just integers, so 2, 3, 4, something like that. Okay. Any questions on that before we keep moving? We're okay for now. So you don't like free trade, right? There's some sweet Nikes, right? So every country, right, has comparative advantage to producing different goods, and whatever goods they can produce at the lowest cost, right? That's why we don't see like the actual production of shoes in the US. I mean, there are some companies that try to kind of make that their brand, but generally, kind of production of apparel is always done overseas. There's a lot of other countries that have a much lower cost in terms of what it's foregoing to do that in the United States. Right? So it's generally why we import a lot of those goods. And then you would dive deeper into the gains from trade. This is kind of just a quick snapshot, thinking about costs to different parties. I think there's an international economics, which I think is I think it might be going on right now. So I think it's taught in the fall, but you would dive deeper into these kind of issues. So that kind of finishes up. I was hoping we would kind of get there last week. We went a little slow, which is okay. So we started thinking about cost. We started about thinking about marginal cost, right? The additional cost from going up one more unit or from choosing to do something. We thought about additional benefits. So we're now going to put this in a slightly different context, which is supply and demand, right? But we're going to try to relate this to what we were talking about when we talked about cost and benefits. So we've got just some kind of terminology. We'll go through it more in depth, but we've got a demand and the supply curve. This is kind of our roadmap, right? So we'll first talk about demand, then we'll talk about supply, then we'll talk about a thing called equilibrium. And I kind of introduce the general idea of equilibrium. It'll make a little more sense in the context of supply and demand here in just a second. So some other term, and don't worry about this. There's more information coming on this. I'm just kind of setting it up. Here's the roadmap. So we're going to start talking about markets, right? And a market is just really anything where you've got buyers and sellers of a product. This could be a good, a service, anything where you're seeing kind of transactions occur for the ownership of a good or service. A competitive market is one in which no buyer or seller has any influence over the price. So for now, we'll think about there's some market factor, we'll call it, it's generally referred to as the invisible hand, all right? It determines the price of this good given what everybody's valuation of this good and the production cost of this good are in the economy. So no one person, no one company has an influence over this price. So what might be maybe a term that you've heard before that would mean they did have an influence over the price? A game that you might have played as a kid. Monopoly, right? So we're not thinking about situations where you have one huge company, I don't know, Amazon, or that dominates a specific kind of industry. We're thinking about something like gasoline. You've got tons of different companies. They're all competing. I mean, down to the penny you to choose to buy gas from them. It's a very competitive market. No company has influence over the price. If they try to set the price higher, what are you going to do? You're going to go half a block down and get gas from the other gas station, right? So we're thinking about very competitive markets here when we start out. And we'll complicate this as the semester goes on. But for now, we're just going to be thinking about these competitive markets. In fact, we'll say they're perfectly competitive, and we'll kind of assume some things away for just a second. So we're going to assume that we're looking at goods that are exactly the same. Gasoline's a good one. I mean, I guess you could argue, I don't know, if you really think that BP's gas is better than Shell's, I don't know. You can sit here and argue that with me. I I don't think this is a very strong argument, right? We're thinking about goods that it's pretty homogeneous, right? They look the same. I always use the perfect example to think about for perfectly competitive markets. I think of as bottles of water, right? Once again, maybe you think Fiji is better. Just think about like a general bottle of water you would buy in like a 36 pack, right? It's the same, it's bottled water, right? And then of course, we're thinking about nobody has any influence over that price, right? So we're going to be perfectly competitive, and the first thing we're going to talk about is demand, right? So the quantity demanded of a good, we're going to think about is the amount that someone or the economy as a whole would purchase at a specific price, right? So if the price of gas is $3, the quantity that you might demand is 25 gallons. If the price instead is $5 for a gallon of gas, well, maybe now the quantity demanded that you have might fall to 15 gallons, right? At these higher prices, you're likely going to be able to buy less of that good, right? Just given income constraints, right? I pull up to the gas station, if gas is 6 instead of 3, $2 or $3 a gallon, I'm probably gonna be able to buy less. Right? So this idea that as we see higher prices, the quantity demanded falls, right? This is gonna be the law of demand, right? Holding everything else constant, right? So like income hasn't changed, there aren't new modes of transportation, right? The only thing that's changed is the price of the goods. That's going to lead to, if the price goes up, quantity demand is falling. That idea is the law of demand, right? These two things are inversely related. And I think that's fairly intuitive, right? When things get more expensive, do you generally buy more of them or less of them? Less. So we're thinking about this inverse relationship. And for anything we're going to do in this class, I'm going to keep it linear. So if I'm drawing a demand curve, I'm going to jump the gun a little bit here. When I'm thinking about, and I'll, excuse me, use this Q subscript D, just represent quantity demanded, right? And it's going to be whatever, we'll start putting different goods on the x-axis so we can kind of think about it a little bit easier. But the more general thing is I'm going to have price on my y-axis, and I'll quite often just use P to represent price. And then kind of here, if we want to think about quantity demanded is what I'm using, or I'm using Q subscript D kind of represent the quantity demanded of this good at different prices. So if I've got this inverse relationship that as the price goes up, I buy less of the good. What's the slope of this curve going to look like? I've got an inverse relationship, so that is price goes up, I'm going to buy less of this good. It's going to look something like this, right? That at the price of 0, people are going to demand that they want to purchase a lot of that good. If it's free, it's $0, right? As that price goes up, notice people will want to buy less and less of it. In fact, there's some price that if you increase the price all the way up to, I don't know, $100, maybe I stop using my car and I walk everywhere, right? I change my lifestyle and I purchase 0 of it. Okay. So you can kind of imagine, I'm just choosing an arbitrary number there to kind of treat. There is some cutoff, right? So the slope of this line, if I'm drawing my demand curve, will always be what? The slope of this line, right, should be negative, right? A downward sloping line means that we have a negative slope. Upward sloping line, we have a positive slope. And that kind of reflects very similar to the production possibilities curve. It's kind of the same idea that there's a trade-off between two goods. Now it's just there's a trade-off between my money and the good. The second good is now the amount of money I have to give up. And so we've got this downward sloping demand curve. I think I have it on this slide or the next slide. I think I jumped the gun a little bit. So I'm going to skip ahead of my example here and we'll come back. Here we go. I'm going a little bit out of order. So how we're going to write this demand curve mathematically is if you have a math class, they usually show you the slope of a linear line is y, that variable y, is equal to m, some value, times your x variable, plus some value that represents the intercept. right? So we're gonna use a little bit different of notation when it comes to law of demand because our Y value is the price, and that's our Y-axis. Good, this is the price, right? And that's gonna be some function of, and I'll generally kind of put the intercept first. So this value A will be, when we're working through examples, will be some number, 5, 3.9, 100, right? And what it will represent to you is it's the starting point for your price. Or the intercept you can think of, that's the price at which the quantity demanded would be what value? It's the intercept, it's the price at which the quantity demanded would be 0, right? And then we're gonna have B, which will be our slope, times our X variable, which we said was just the quantity demanded. So we can think of that, however much is demanded of this good, right, will correspond to some price that people are willing to pay. And I can kind of think about it, well, what if quantity demanded was 0? What's the only thing that comes out of this equation? Well, anything times 0 is 0. So that's why the intercept tells you the price at which the quantity demanded would be 0. And then as you want to know, well, how much would I have to set the price for the quantity demanded to be 1? I could plug a 1 in here. I'd have some values here, and I can compute the price at which someone would buy 1 unit. And then what's the price if somebody wanted to buy 2 units? I plug a 2 into the quantity demand, and I could compute the price at which they would demand 2 units, and so on and so forth. Right? But here, if B represents the slope, B, I said, is always going to be negative, right? When it comes to the law of demand. So we've got B is always going to be negative. The intercept value will be where quantity demand is equal to 0. I'm using some goofy Zoolander example, which we'll kind of backtrack on and then look at a little more. But here I believe the price I had set for the quantity demand to be 0 would have been $6, right? So just kind of getting a little bit of the mathematical side of things, or kind of the mathematical visual on a graph. This is what we're going to be doing here with the demand curve. So we'll go back and think about demand schedules here. Make sure I set everything on this slide. So we've got linear demand, we've got this inverse relationship with this negative slope to our demand curve. Then you think about demand schedules, right? So I kind of already alluded to this, like if I plug in different quantity demanded, I can come up with what the corresponding price would have to be for people to demand that much. Okay? So I've got Orange Mocha Frappuccino that you've never seen, you later go back and watch it. Great movie. But at different prices, I can figure out what the corresponding amount demanded to be, right? If I charge $0 for these drinks, maybe someone, this one person, I guess, would drink 12 of them, right? Even if it's free, right? There's kind of like my beer example. And it doesn't matter if it's $0, I'm not going to consume an infinite amount, right? And then as the price increases, this individual is choosing to buy less and less. Now notice here, I kept it nice and easy. For every $1 increase in the price, we're kind of seeing quantity demanded fall by 2 units, right? So going from 0 to 1, we see quantity demanded go from 12 to 10, right? It's falling by 2. And then if you increase the price all the way up to $6, this person won't buy anything. Okay? Well, I could plot these points on a graph, right? I could just use quantity demanded as my X value, price is my Y value, and basically I'd be just, this point would be what? When quantity demanded is 0, the price is 6, all right? And then when the price is 0, quantity demanded is 12. And I could graph all the other points in between, right? On the X value, quantity demanded is 2, price would have to be 5. So I could kind of think about, I could graph all these points on my demand curve, but because I'm keeping it linear, it makes it easier. Always graph kind of the price where quantity demanded is equal to 0, and then graph the quantity demanded when the price is 0, and just draw a line in between, right? And then any kind of combination of price and quantity demanded, you should be somewhere on that line. But even if you want to do it just using these, 7 different points, right? You could do that, right? So I go ahead and I graph the first one, second, third, fourth, right? I'm just graphing these different X, Y combinations, just like I would graph any 2 variables. Okay? and I draw a line between them, I've got my nice demand curve here. We'll call it a demand curve, but for us, we're always going to keep the curve linear, right? In practice, demand actually looks something like that. The math gets more complicated. We're going to punt on that, right? As if you're going down further into Econ 301, you'll start dealing with that stuff. So we've got this nice demand curve, this demand schedule, right? The demand schedule just refers to kind of the table version, right? So we can take that demand schedule, put it into a visual version, the demand curve. Okay. Talked a little bit about this demand equation already. When you think about the slope, this is another thing that I want to kind of hammer down here. Where are we at in time? Also, I'll rant early. I'll get to so I'll rant today. I hate this with the clock. Like, what's the point of me being able to see the time? Like, I just mean you're counting down the seconds to get out of here. I can't see the clock back there, so unless I bring a watch or I got my phone, I gotta like crane my neck or awkwardly like look around the screen. But I didn't come up with the design, so I guess whatever. So one way we can think about kind of this demand curve. Let's say I've got 6 plus 1/2, not 2x. So what this is telling me, right, is that my intercept value, or the price that I'm going to start out at when quantity is equal to 0 is 6. What the slope is really telling me is that for each additional 1 unit increase in demand, the slope represents how much you would have to see the price fall by for people to purchase 1 more unit. So why is that the case? Well, let's think about an easy example. Quantity is 0. What's the corresponding price that would result in quantity demand of 0? 0 times 1/2 is 0, so that price would be the 6. If I go up by 1 unit, my quantity demanded is now 1. What's the price at which quantity demanded would just be simply 1? 1 times 1/2. And actually, what did I do wrong here? I should have a negative sign, right? It's always a downward sloping line. So 1 times 1/2 is 1/2. 6 minus that would be 5.5. So the slope is telling me how much of a price change I would need to increase quantity by 1 unit. I can show you another, right? What if I go from 1 to 2 units? What's the price at which quantity demand would be 2? I plug 2 in. 2 times 1/2 is 1. 6 minus 2, 5, right? So to go up by 1 unit, what had to happen to the price? It had to fall by whatever that slope is. Right?
So you said in the equation it's negative instead of positive.
Sorry, it's always going to be negative, right? I think I have it maybe still over there, right? B is always going to be less than 0. B is always negative. We should have, demand curve is always going to be downward slope.
So we should put it as a factor sign.
Yep, you should have a negative sign right here. Right? Well, that one I put a plus sign, but if B is always less than 0, it ends up being that. So you're adding in B, but for demand, B is always going to be a negative value. Right? So we've got this negative value that kind of represents how much money I'd have to give up to get 1 more unit of my X good. This sounds similar to production possibilities curves. When we want to get 1 more unit of the X good, what did we do? We calculated the slope. The slope of our demand curve tells us the cost, how much money we have to give up for 1 more unit of that X good. Just now we don't have to do it in terms of jets or automobiles. We can do it in terms of dollars, right? That's our Y good. Right? So the slope of this line, the slope of our demand curve, really represents the cost of 1 more unit of that X good, or increasing quantity demanded by 1 unit. Hopefully we're kind of seeing the connection a little bit, all right? Another way to think about this is the law of demand is really telling us this price is saying, okay, if someone buys 2 units, you would have to have the price set at $5. What that's really telling you is that if someone's willing to pay $5 to purchase each one of these, right? So $5 for the first, $5 for the second. It must be that that marginal cost of $5, right? Whatever that price is, it must be less than what? The person's marginal benefit. So really what the demand curve is telling you is saying this person purchased that second unit would be willing to pay up to $5. Right? They're going to choose to purchase that second unit at $5. So what that tells you is they must at the very least have an additional benefit of $5. Right? At that point, their costs, their additional benefits will be exactly the same. And we said people will always choose to do something or choose to buy something as long as the marginal benefit is greater than or equal to the marginal cost. If those two things are equal, the person's no better off or no worse off. So we say they're kind of indifferent, but we always just kind of include that equality to make it a little bit easier. That person, as long as that marginal cost at $5 is less than or equal to their marginal benefit, they would choose to purchase that good. So this tells us that for that second unit, the marginal benefit must be at least $5. Right? Otherwise, this person wouldn't choose to buy it.
How do you figure that?
Like, how was I coming up with these values?
Yeah, so how do you know that 5 is the correct price?
Yeah, so that was by just plugging in different values for quantity here, right? So I plugged in 0. If they purchased 0, what would the price be? Well, 0 times a half was 0, 6 minus 0 is 6. If they bought 2 units, what would the price have to be? Well, given this demand curve, plug your 2 units in here, 2 times 1/2 was 1, 6 minus 1 was, the price would have to be $5. So really, it's that demand curve is telling you the price at which people would be willing to pay up to for different quantities of the good, right? And to come up with those prices, I'm really just, well, what quantity I'm interested in. Am I interested in the second unit? Or maybe I'm interested in the 5th unit. So how much would somebody be willing to pay for that 5th unit? Well, I'll get into my demand curve. 5 times 1/2 is what, 2.5? 6 minus 2.5. I know that for that 5th unit of the good, right? Person's going to buy, quantity of 5 of whatever this good is. Price would have to be as low as $3.5. That's just really just coming from this demand formula. Another way of thinking about this is these are the different quantities that this person is choosing to purchase at these different prices. You could do your own demand schedule or something, right? You had a long introspective look. You could say, look, how many gallons of gas would I buy today if the price was $1? How many if it was 150, 2? You could think about I only have so much money. Obviously, if the price goes up, I may choose to buy less and less, especially if I'm on a fixed income like you probably are, right? So you're really just mapping out, right, how much you benefit, right, at these different prices, right?
So yeah, that's what my question is. You plug in different numbers, you get different, answers. How do we know which one is the benefit of why?
Oh, gotcha. So the marginal benefit is going to be different for every single unit you buy. So think about it this way. It goes back to what I was talking about last week with the beer example. The first beer always has the highest marginal benefit. And the second one a little bit less, and the third one a little bit less. So we've got the fact that marginal benefits are declining, which is really what the demand curve is telling us. It's saying for that first unit, I think if we calculated this out, it would be $5.50. So for that first unit, the person's marginal benefit must be $5.50, right? They pay up to $5.50. If the cost goes any higher than that, they don't purchase that first unit, right? Their marginal benefit would be less than the cost. Well, for that second unit, if the price was $5.50, this person wasn't buying it, right? In order to convince them to buy that second unit, it had to be that you lowered the price, right? Here, price is just the marginal cost. You have to lower that price such that their marginal benefit is greater than or equal to the price at which they decide to buy that second good, $5. So the marginal benefit is different for every quantity of the good that you buy, right? You're always going to be willing to pay more for that first unit than you are for the 100, right? Or if I'm looking at the exact same car, think about this way, the exact same car, same year, model, mileage, everything. I'm going to pay a lot more to buy one of those than I am to buy the second one. right? Have the exact same, I might zero, right? The demand curve for the same automobile might be like a straight line, right? I buy one and then zero after. I don't want to have really the exact same car. I mean, non-millionaires is a little bit different, right? For the general person, right? That second unit, marginal benefit falls dramatic. Now, I usually don't see as dramatic of a fall, but as I buy more of a good, I'm willing to pay less and less to kind of keep buying more and more. Right? The very first unit I purchased was the one that had the highest marginal benefit. So another way of thinking about this demand curve that I try to always write this out is that if you plug in different quantities, it's giving you the price that would result in the person buying that amount. But that price is really just reflective of that is going to be the point where marginal benefit becomes greater than or equal to. At what point does it become greater than or equal to? When they're equal. So you can actually think about the demand curve, like here. Really, all that price is telling you is the willingness and ability of that person to purchase different quantities of that good. So when I'm plugging in different quantities, yes, I'm getting the corresponding price, but by plugging in these different quantities into my demand equation, it's also that price is reflecting to me what that person's marginal benefit is. Because we know they'll pay up to whatever that marginal benefit value is. So pay up to, what are they paying? They're paying whatever the price of the good. Right? So you can kind of think these are really the same thing. The price and marginal benefit on the demand curve really telling you the same thing. The goal is not to necessarily be anything. The goal of equilibrium, eventually kind of yes, the goal. We won't talk about that until next class. All right, we're setting ourselves up. We've got the demand curve, which reflects the marginal benefit to the person buying the good. Next class, we'll talk about who's supplying, right? Who's producing this good. And once we have both of those parts of the equation, we can talk about equilibrium. Okay? So we will pick up in this next class. So before you guys get out of here, should have at least a couple minutes. And should be a real easy one. I just want to see if I can get this working today and get everyone who's registered to be able to show up. So on your way out, whatever, if you have a physical clicker in the app, try to respond to them. Just leaving it open. Any letter that you feel like is your letter today. There's no right or wrong answer. Everyone who responds should get 10 out of 10 points for the day. If you're using that online app, let me know. I think you guys have problems.
What's like the letters thing?
Oh, so the frequency I keep it on is always AA. Just because that's usually the default, it's usually the easiest. I don't know if I so just hit if you've got a physical version, hit whatever letter, I'll be able to see it. If you've got an online version, just let me know if you're having issues seeing the course pull up.
Yeah. I don't know if it's the right. Here. This one.
Nope, it should just be Econ 201.
Nothing pops up.
Yeah, nothing.
Yeah.
Okay. So this is why I did this trial run. All right, so let me see here. I hate to keep you guys in. We got 2 more minutes. Let's see if I can figure this out. So it is for some reason disabled. Oh, yeah, let me try something else. Hang with me for just another 30 seconds to see if I can get this to work. Why won't it? See if it'll let me set this to be yesterday. So let me know for those of you who have the app, once this gets pulled up, if you can now see it once I start it. If not, then I've got some troubleshooting to do before Wednesday, and I'll just punt the points. So is it showing up now? No. All right, I will work on this so that Wednesday, we should be actually using them for points. Everyone's here today, so it wouldn't really influence anyone's grade 10 out of 10. I'm just trying to make sure that we can kind of use this. So Wednesday, I'll be using iClickers. Hopefully I have it figured out for this online app. Other than that, any questions, feel free to reach out, or I'll see you on Wednesday. Why would this not work? Hey.
Says that like, oh, sorry. It's just like, I don't have attendance.
Oh, don't worry about it. I was trying to play around and make sure. Yeah, I was messing around with it this morning to see if it worked, and I had it working for mine in my office.
So I'm like in the right spot, though, right?
Yeah, that's the course name. Let me see.
I don't know where the sign is. Hold on.
Oh, don't worry. It should pop up there. I don't know why it's saying. They just changed like their reef thing, and I wonder if I don't have the most up-to-date version. So I'll play around with this before Wednesday.